plane, my part of the project for the final is the Wilcoxon signed rank test. And today I'll be presenting it from my smartboard, and I'll do it like I present it for my class. The Wilcoxon signed rank test, well, what is it? I'm going to do like I would do for my class. We're going to start out with vocabulary from Wikipedia. The Wilcoxon signed rank test is a non-parametric statistical hypothesis test used when comparing two related samples, matched samples, or repeated measurements on a single sample to assess whether the population mean ranks differ. It can be used as an alternative to a paired student's t-test or a t-test for matched pairs, or the t-test for dependent samples when the population cannot be assumed to be a normal distribution. I have lived off of Wikipedia through this whole entire, not Wikipedia, well, Wikipedia too as well for some, but YouTube for this whole class. Some of the things in the book and some of the videos in the book and even some of the other activities in the book, I could get some of it off of that, and then some of it coming in and out, I struggled with it. But YouTube, some of the videos, it didn't use as many numbers, it broke it down. And so the video that I chose for this, I looked for charts. I tried drawing my own charts. I tried making my own charts, graphs, doing my own formulas. And I even tried Microsoft and some different things to try to make it look really nice. And I couldn't really come up with anything I was really satisfied with. So I went with this video from YouTube. Now, I don't like it in the fact it does not have enough of the information. It needed to have had 20 numbers, but it only has 6 that it's using in the hypothesis that it's got together. But it gives you a smaller amount so that you can see the formula, so you have the information, but it gives you the information in small amounts so that you understand the Wilcoxon, and you can see it and you can get the idea of how to work the formula. So we're going to look at the video. It's simple explanation of how it works. It's even got the Z table from our book, the little fold-out we had, and it gives you a little simple step-by-step, and we're going to go through it. I'm going to point out some things as we go along, like I would teach my class.
Similar to the Mann-Whitney U is the Wilcoxon signed ranks test. Now, the Wilcoxon signed ranks test is a version of the dependent samples t-test that can be performed on ordinal or ranked data. So here's some ordinal data displayed in
it's small, it's 6 numbers.
I'm asking, is there a difference between before and after using an alpha level of 0.05?
And the alpha level, they're going to use 0.5.
So we're going to do a Wilcoxon signed ranks test.
And it's just giving you
just like
6
any other
simple
statistical
steps.
test. And our first step is to state the null and alternative hypotheses. Now remember, this is just like a dependent samples t-test, so our null is that there's no difference between the 2 treatments, and the alternative is that there is a difference between the 2 treatments. Our alpha level, as I said, is 0.05. And now our decision rule. This is going to follow a Z distribution. Now usually you want your sample to be greater than 20. We actually have 6 people, so that's definitely not greater than 20. But we're still going to go ahead and do this. I just made the sample size smaller, so it would be easy for us to do, and it would be easy for you to understand. But realize that when you're doing this test, you want a sample size of at least 20 in order for it to follow the Z distribution. But I'm going to continue on. So alpha 0.05, Z test, we end up with a critical Z of 1.96. If you don't know how I got that, you can go back to one of the lectures on Z scores, just to double check. So our critical Z is 1.96. That means that if the Z we calculate is less than negative 1.96 or greater than positive 1.96, we will reject the null hypothesis.
But we got to find out first. We have to calculate our.
Here is our data, just organized in different ways so we can work with it. And now we're going to calculate difference scores. Remember, this is just like a dependent samples t-test. We have difference scores. So now we're going to throw away the original stuff.
We just want to work with our difference and nothing else for this.
So now what we're going to do is rank these difference scores.
And that's where the rank comes in. We're going to rank it. And this is our lowest, so it would be 1.
So our lowest number, negative 14, is ranked 1, and our highest number, 21, is ranked 6.
And
so
then
now
we're going to create,
we're going to add together all of the scores for the positive ranks, and we're going to add together all the scores for the negative ranks to get these two
since we only
different
had that
R's.
one negative number, that's
Now,
all
our
we have is
positive
that.
ranks are 4, 5, 6, 2, and 3. Those are all associated with positive numbers. So our positive R is 20. And our negative R is just 1, because rank 1 is associated with negative 14. And that's the only negative number. So we just have 1 there. Now we're going to use this to find a T. T is just the smaller of those two numbers.
The smaller
so
of
our
the
T
two
in this
numbers
case is
is
going to be 1. And now we're going to use this T to calculate our Z.
And our N is going to
Now,
be...
this equation is actually pretty easy. All we need
amount of
is
numbers
T
we have.
and N. Our T is 1 and our N is 6 because we have 6 people.
So we have 6
So
people.
we
If
just
we'd
put
had
all that
20
stuff
people,
in
the
there.
N would have been...
And if you have a calculator, you work through that.
And
It's
there's
not
our
too bad.
6.
You actually find a Z of negative
Plug it in.
1.99.
So there's our
So now we
number.
can go to our
Then we come
results.
back.
Remember, we were going to reject if we had a Z less than
Here.
negative 1.96 or
So
greater than
there's
positive
our Z.
1.96. And we had a Z of negative 1.99. That's just less than negative 1.96, so that means we can reject the null hypothesis. And we're going to conclude that there is a difference between the before and after
So there
years
is.
using a Wilcoxon sign.
And there's our
test.
important terms. Results, alternative hypothesis, decision rule. I like this video because it breaks it down into smaller terms. So when you do start dealing with larger numbers, larger amount of data, and even like confusing word details, word problems. You know, I think about my students that need differentiated information, students that struggle, things like that, students like me that, you know, I need it broken down into smaller parts first before I can take on bigger information. And this is what I've had to do for myself through the whole statistical process of taking this class online. So it's been important to me to take these smaller parts, then build on the bigger parts in order to take the test, to do the information, to do the homework, to do the other things. Because I have struggled with having to take this class in the beginning because of the fact that I am a geology or geoscience education major. Why do I have to take this? I dig fossils. I dig in the dirt. I teach kids science. I want to be a geology major. I want to eventually teach geology or teach college geology. I like astrophysics, not statistics. My kids like trying to figure out how much water, how much air pressure is going to make this go farther in the back of the school building. How much toilet paper is it going to take to build the solar system down the hall? Or if we use a roll of toilet paper, how far Mars is going to be? Is it going to be at a certain teacher's room? Or how much roll of the toilet paper is it going to take? Or how many rolls of toilet paper is it going to take to get all the way across the schoolyard? So I did some research on my own. I went through and looked up some things thinking, would I use statistics in geology or geological education? Because, or would I use the Wilcoxon rank test to help me in anything I use? And I was very surprised. My big thing right now is they've cut my science time back in elementary school, and I'm afraid they're going to do away with science in elementary school. And there is research out there, and I included it in here, and you can go look at it, from the International Conference of Learning and Science from 2000, and that was the earliest date I could find. But I have included this in my information, and I'm going to keep this Wilcoxon rank test that they did in this and the information that they did for my personal benefit to keep for my school system to show that they did testing on students and their learning and their problem solving for science that helped them in math, reading, and language arts. And so I think that it's important that they have this and know that if they take science out of elementary schools and out of early learning, that it will hurt them in the long run. And so they ranked those scores and they ranked their abilities and things. So yes, this will help me, and yes, statistics has. So, yes, I do need to use it. The references I have, and then I included a thank you and a video that goes along with my fossils. So, thank you very much.